Hello, hi, Assalamualaikum. Year 9 student, welcome back to my class, physics class for week 37. Okay, for today, let's proceed to the new topic, which is thermal expansion. Okay, this topic is quite long, so I will divide this video into 6 parts. So it take about 3 weeks. So guys, please give me a full cooperation. If you not understand, if you don't know how to do the exercise, okay, please contact me, WhatsApp me personal. Okay, I will assist you one by one. Okay, as you know, in IGCSE syllabus we have 5 section, and now we still in the second section, which is thermal physics. Okay, so thermal physics, after this we have properties of wave, section 3, and section 4 is about electromagnet. Okay, these three section is quite it's very long. Okay, so please give me a full cooperation, right? Okay, so let's start. For the thermal expansion, okay, it's include the expansion of solid, expansion of liquid, and expansion of gas. Okay, so we will I will explain to you one by one, and I will show you some example. Okay, so you can refer your textbook page 81 until 84 for the first part, which is expansion of solid. Okay, let's start. Okay, this slide is just introduction. Okay, before this we already learned about the kinetic theory. Remember, right? So particles are constantly moving and have kinetic energy. The higher the temperature, the faster they move, so the more kinetic energy they contain. Okay, so before this you already learned about the solid, liquid, and gas, right? So all the particle inside the particle of solid, liquid, and gas are moving. For example, solid are vibrate, right? So when we give the energy, okay, so it will vibrate faster, right? So in other words, when we increase the temperature, or when the particle gain the energy, which is heat, right? So they will move faster, meaning that they will expand. Okay, when they lose energy, when they lose heat, they will contract. So that's why we have the change of matter, which is solid turn to the liquid, liquid to the turn to the gas, gas can turn to the liquid, liquid can turn to the solid. Remember, right? Okay, so please remember this keyword. When matter is heated, it's expand, and when cool, it's contract. Remember like that. Okay, so look at here. Energy will flow from a hotter object to a colder one. Particle in the hot object will lose kinetic energy, whereas particle in the cold object will gain energy. So meaning that like this, the energy will flow from the hot object to the cold object. So as analogy, I give like this. For example, I have hot water in a cup, okay, and then I bring the cup into the cold room, okay, and then after a few minutes you will notice that the water become cold, meaning it's not hot anymore, right? So why that happen? Okay, that happen because of the energy from the hot water are transferred to the surrounding, which is the cold room. Okay, so like that lah. So that's why the cool room, the cool surrounding just now gain energy from the hot water. Okay, so look at here. Energy will continue to flow until both objects reach the same temperature. Object at the same temperature will have same average kinetic energy per particle. So after they reach a same temperature, that one we call it thermal equilibrium. Okay, look at here. Temperature and heat the same? No, because a spoonful of boiling water 100 degrees Celsius will have less thermal energy than a beaker of boiling water at the same temperature. So for example, here in the boiling water, this one is 100 degrees Celsius, right? And then I take one spoonful of water. Okay, they still have a same temperature, which is 100 degrees Celsius, but they have different thermal energy. Okay, why? Because it depend on the volume. This one is more thermal energy than this one. Understand? Okay, that one just introduction. So we start from here. Okay, look at here. Liquid expand more when heated than solid. Okay, and then gas expand more when heated than liquid. Okay, so when heated, solid, liquid and gas gain thermal energy. The particles start to move about more. They are about more, so their vibration take up more space. So there is expansion in all direction. The opposite is true when temperature falls. So the material will get smaller, contract. So in other words, it's like this lah. Okay, when the matter is heat up, means they gain energy, they will expand. Okay, when the matter, solid, liquid and gas lose energy, they will contract. Okay, easy like that. But gas will contract, or gas will expand more than liquid, and liquid will expand more than solid. Understand? Okay, so for proof this theory, look at the some example. Okay, so the first part I will explain about the expansion of solid. Okay, look at here. This is the bridge. Okay, okay, why okay, why engineer build the bridge have gaps to allow for expansion. Okay, why the engineer build the bridge must have a gap like this. Okay, this is not the crack or the bridge is broke. No, okay, this is, we call it expansion gap. Okay, so bridge have gap to allow for expansion. Roller may be used at one end so that movement can take place. Okay, as you know, solid also can expand. So in hot day, okay, in a hot day, okay, so this solid will expand. So in hot day, it doesn't have this gap. Okay, but in the cold day, it will contract. So that's why we have the gap. So that's why all the engineer build the bridge like this. Okay, this is one example. Okay, the second example, look at here. Your textbook, page 81. Okay, you can read in here. Okay, if you look at the picture in your textbook, okay, this is the railway lines. Okay, so why the railway lines is built like this? Okay, have a gap like this. Okay, so this gap, okay, like this. Okay, when I zoom, okay, actually the gap is like this. Okay, so okay, this one we call it expansion joint. So in the hot day, this one will expand. Okay, and the cold day, this one will contract. Okay, the third example is the electrical or phone line. Okay, when you look at the rod, okay, you will see the cable when during the cold day, the cable will have a straight line like this. Okay, but when hot day, for example afternoon, the cable will it's not straight, it's just like, okay, this shape is like this. Okay, okay, look at this experiment. This experiment show how does the solid expand and contract. Okay, so before heated, okay, before heating, so it can pass, the bulb can pass through this ring. Okay, and then they heat the bulb for 5 minutes. See, when the bulb or the solid gain energy, the particle expand. Okay, so what happened? See, it cannot pass through the ring. Why? Because the solid already expand. Okay, okay, after after the bowl is cool, or you dip into the cold water, okay, then it can pass through the ring. Okay, see. Okay, this is another example. Okay, like I explained just now.
Summer and contraction in winter, railway tracks can be damaged. To avoid this, they join taper dams overlapping.
So that's why they build the railway have the expansion joint. If not,
At
it's become
contraction
like
in
this.
winter,
Okay.
railway tracks
Okay.
can
No,
be
if not
damaged.
have the expansion joint, it's become like just now. Okay. Later is it's dangerous for the train lah. Right.
These are kept sagging in summer, so that when they contract in winter, these do not break.
Okay, so that one is the example of the thermal expansion in solids. Okay, if you want to no, I mean if you want to watch more video, okay, you can type the example of thermal expansion in solid. Okay, so that's all for the first part of the video. I will continue the second part of video about the application of the thermal expansion. Okay guys, thank you.